Alright everyone, so today we're gonna go back with the Maze 3. So this is again another upgrade from the Maze 2. If you haven't watched the Maze 2 and the Maze 1, I highly recommend you to try to visit the video or try to solve that beforehand. This is an upgrade version of those two. So yep, highly recommend that. And for this problem, let's say, just to recap the problem, so it's just basically the ball right here is the start position and the hole right here is our end position. The ball can only move, it can only roll until it hit a wall or not, right? So in regular traverse in grid, usually you stop right here, you choose 4 direction, but for this one you go all the way until you hit the point. So let's say this ball is trying to move up, it can only stop right here, right? So okay, and also for this problem, it wants us to find the shortest path to reach to the destination. So whenever you heard about shortest path, you're gonna do BFS, right? And then especially for this problem, since you're gonna count step, let's say this one is 1, 2, 3, 4, 5, 6, right? And I will choose another color. If you choose another path, this one is 1. Let's say you go to the left, 2, 3, 4, 5, and 6 right here. So in this case, since we have 2 paths, right, from here to here, and of course we're gonna count each step, right? Even though the ball it can only roll until it hit the wall, we have to count on the step that is roll over. So this is the step that is count. So as you can see, we have one right here and we have another one here, right? And because of that, let's just put S right here. Because of that, we have to use a data structure called a heap. And basically a heap, it would always choose the minimum step, right? It would choose the minimum. It will whenever you pop current location from the heap, it always gonna choose the location that is the least step. Let's say you're at this position, right? This one is 1, so it's always gonna choose 1, but since this one is in the wall, it's not gonna work. Then it's gonna either choose this side or choose this, right? This one is already invisible, so it's not even in the heap, but it's gonna choose this one, right? So it helps us to maintain the shortest path, right? The one hard step in this problem is you have to give out an instruction. So let's say this one you go up and left, right? So in your result array, you have to have the up, left, right? And then this one you go left, up, left. So left, up, left. You have this two, right? We have these two array. You return this because it is lexical order is smaller, so you return the smaller lexical order since this two is equal. And then since we have to give out an instruction, right, we need to maintain that instruction. We just have to add another state into our heap, right? Let's say our heap is store our step, right? We have to keep track of the step. We also need to keep track of the instruction. The nature of the heap is it's always gonna, for this one, if the step is equal, it will go to the instruction, right? Since this instruction is lexical order is lower, it will return the lower instruction now. So we just need to add another instruction line here. So let's, in here, just save some time, right? I already did the Maze 2. If you haven't watched Maze 2, I highly recommend watch that. But for this Maze 2, I would just have a few of modify, as you can see, how you can add an extra instruction into the heap, right? And then one more thing, let's say the ball is right here, right? It's row, so the end destination is right here, right? But since it moved over the hole, we have to have an if function, an if statement to check that, oh, if it's already row on the top of this hole, so we return that location immediately. So it return the actual instruction that we need. So other than that, let's try to modify this code right here. everything's gonna be simple. It's just gonna go, let's say our regular direction will be not just these. It will be a hash set, a hash map of a key, which is this one is going this one is go to the right, this one is go to the go down, this one go right, this one go down, this one go to up, and this one go to the right. So yep, this one go to the right. And then in our BFS function, we also need to have some update. So we have visit right here, we have a queue right here, we have a queue right here, and we have this. So we just need to add the instruction, right? So initially our instruction is going to be empty, nothing happened here. And our step row, we need to have our instruction. Yep. And our destination right here, because we changed that to whole, so we have to change this to whole. Same with the ball right here. And then when we return the instruction, we do not return step, right? We add the row and the column, correct? Then we, instead of the direction row and columns, we just have the keys, right, of the direction dot key. And we have the, right now we don't need the direction right here. Of course, we're gonna return a row, new column, the new step, and our new instructions, right? New instruction right here. And here we just need to pass our key in, so don't need to move it. Pass our key in for keys. I need to add our key in. We need to add our step, of course, and we need to add our current instruction, right? Yep. And then continue visit, that's fine. We need to push our new instruction in, right? And then at the end, on the top right here, say if it's not returned, we return. So impossible. And we just change our row right here. For our row, we need a new step, row, column. We also need our row and direction. So in this one, we just remove it. We just put our key in here. I just need direction row, direction column equal to the direction of key 0. I'll just say this 1, something like that. We have a direction. Then we just do our can row like regular. We plus our step, right? And we plus our step. Then if the row equal to, so if this case happen in a moment, so this is what I say, when it's go over the hole, we have to return that spot immediately. So it's just that. Then we just return that immediately. So we just return the same thing, right? New step and instruction. Wait, we don't have our instruction, so I just put my instruction in here, right? Instruction plus the key, right? And same thing right here. New step plus the key. Hit a wall. This not changed. Wall, making sure. Instruction plus key. That is pretty much it. Let's try. See what happened. Alright, so make a mistake up here. So this one should be 1 plus 1. So this one is left. Oh wait, this one should be right, and this one should be left. So something like that. Try to submit it, and it's passed. So just a quick modify. We are able to solve a hard problem. This hard problem is just basically from the smaller hard problem, and you develop from there. So hope you like the solution, and see you soon on our next video.